Hi there, my name is Ron Rogers, and I'm going to talk about a deadly design deficiency of the Concord that led to its final demise as an operational supersonic aircraft. It's an amazing design, but it had a very serious design flaw, and I'm going to talk about that in detail. But a little history on the accident. On the 25th of July 2000, Air France Flight 4590, which was a Concorde passenger jet from Paris to New York, crashed shortly after takeoff. It's only fatal accident in 27 years, which is quite remarkable given this deficiency. 109 people on board the aircraft died, as well as 4 on the ground that were in a hotel it hit. Now, what happened is the aircraft ran over some debris on the runway that was left by a Continental DC-10-30. It was a little fragment called a wear strip out of one of the engines, about 17 inches long and just over an inch wide, but made out of titanium. And what happened is the Concorde ran over this piece of material, and it damaged the tire, caused the tire essentially to disintegrate. Now, they hit this piece of strip by when they're doing 185 miles per hour, and the tires exploded. Now, the interesting thing is the tire did not actually penetrate the fuel cell. It actually caused a shock wave that caused the fuel cell to fail, obviously, at its weakest point and start spewing out fuel in the number 1 and 2 engines. It also damaged the gear, so they were not able to retract it. They figure that the tire fragment hit the underside of the fuel tank at roughly 310 miles per hour, and it weighed 9.9 pounds. So a 10-pound object at 310 miles per hour has a lot of force. Kinetic energy is 1/2 mv squared, and that's an equation that's very important in this. Now, you may say, man, 185 miles per hour, that's pretty fast. Well, the efficient design for a high-speed supersonic aircraft is a delta wing, and unfortunately you can't put slats or flaps on it, and so you have to have a lot higher speed. So that's the first part of the issue, is you're going to be operating at very high speeds, and high speeds are always dangerous because the old kinetic energy equation, kinetic energy is 1/2 mass times velocity squared. You ever notice on a takeoff roll, like the first part of the takeoff roll below 100 knots, it goes pretty quickly. Second part, it seems to slow down. And you wonder, well, why does it slow down? Well, the simple thing is you're generating kinetic energy with the thrust from the engines. And 60 squared, 60 miles per hour squared, is a lot lower number than 120 miles per hour squared. So it takes a lot more energy imparting to the aircraft to advance. Now, another thing about this design, and it's the U.S. had a design. It's hard to complain about the Concorde because the Boeing design never got off the ground. But the guy who was the chairman of the new Aircraft Evaluation and Certification Committee before me actually worked for Boeing on this design. But one thing they did was they separated the engines, because the problem on when you cluster engines like this, and this occurred, engine number 1 and 2 failed, and they got partial thrust back on number 1, but they lost essentially, 2 engines. They had trouble with an elevon that was damaged, which caused them roll control issues. And they also ingested hot gas into these 2 engines right there, and it caused them to initially surge and fail. So they've got the gear hanging, they've got fire, they've got a controllability situation, and only 2 out of 4 engines. And anybody who has a multi-engine rating knows that you don't lose half the thrust. You can lose up to 80% of the excess thrust when you lose one or one engine. In this case, we got a pair engine, so it's equivalent of losing 1 out of 2 engines. So they lose a lot of extra thrust, and they are really behind the power curve on this whole thing. And supposedly they were actually slightly slow on the takeoff. The aircraft was just about 2,000 pounds over maximum gross weight, which percentage-wise is not terribly significant and wasn't really a big factor. There are a couple of little things I'm not going to get into. But, okay, part of the issue with this is the delta wing causes you to fly at very high speeds. Now, this aircraft, was produced a long time ago. And when I flew with the Airbus test pilots, every single one of them had been almost without an exception a Concord test pilot, and they let you know about that. But I mean that was pretty cool because they had a Concord setting down there at Toulouse that all of them had flown. But let's talk a little bit about aircraft design here. Now, if it weren't for Cain and Abel getting into a fight way back when and led to the development of better clubs and better weapons and bows and arrows and stuff like that, if it weren't for conflict, we would not have most likely technological advancement, and we would be walking everywhere naked because, we never developed airplanes. But that's not the way history has unfolded. The B-58 and development comes obviously through the military realm because the military needs the best and most capable performance, and they're the ones that always push the technology. And of course, it's a lot more acceptable to have issues with military aircraft than to just plop these designs on the civilian realm. Now let's talk about the B-58 Hustler. Now this was an aircraft that is often considered to be ahead of its time. And you notice it has the delta wing platform, which is very efficient at high speeds. And you notice how the engines are separated. So if you have a problem with one engine, it's not going to necessarily, like it disintegrates, propagate to the others. But you have a little issue at high speeds of having an unstart where you have disturbed airflow, because a jet engine cannot take supersonic airflow into the compressor. It has to what's known as shock it down. So it is the inlets are made so you form a shock wave and you get lower speed air. And often it gets very complicated and the equations just get amazing. But you can have oblique shocks, normal shocks, but you got to get the air down to subsonic for the compressor to accept the air and being able to operate, unless you have a scramjet. And we're not going to get into that, but because that's kind of a little bit how the SR-71 operates in certain phases. But anyway, I'm digressing here. The whole issue is the B-58 was ahead of its time. It really was. And it did not have as sophisticated a flight control as it should have. And if you would get an unstart on one of the engines and the airplane ended up going sideways, which it could very easily because these things have a lot of drag at high speed, it would end up going sideways, and the biggest piece you would recover would be one of the throttle knobs, they used to say. Now, of course, we're talking about a very advanced aircraft here, the SR-71, and this never went out of the realm of, very capable pilots operating it. And this aircraft had a lot of issues. Unstart was one of the biggest ones where it could end up going sideways, and it was just basically a very dangerous and high-performance aircraft to fly. And Bob Gilliland, that's me and my wife there at a Society Experimental Test Pilot meeting. Bob Gilliland was the chief test pilot on this and did all the first flights. And of course, it was extremely secret. And it's one of those things where you come home and, well, what do you do for work? Well, you make up some story, because it was very secret for a very long time. But he had a lot of stories, and I talk about him in another video. But he suffered a lot of very extreme emergencies and kept control of the aircraft. And it had a very good history until it was finally retired, but it had some significant accidents. But again, it's on the cutting edge of technology. Okay, the XB-49. This did not have a sophisticated flight control system, and it had pitch stability issues, basically being a flying wing. Edwards Air Force Base is named after the co-pilot, Captain Edwards. And why would you name a base, military base after the co-pilot? That's because the head pilot of it was a contractor pilot, and you don't never name a Air Force Base after contractor pilot, but I talk about that in another video. But anyway, the airplane had issues, and there's a lot of politics with this and the B-36 and things like that, which might actually make a good video to talk about that in the history aspect and that. But anyway, the aircraft was eventually canceled and scrapped, although quite a few of them had been built. But here we got the B-2. And the B-2 had the sophisticated flight control systems that would allow this type of aircraft to fly very well and very successfully. So technology advanced to the point where the issues were overcome, and Funny side little thing here. Bruce Hines was a chief test pilot on that. I knew Bruce from out at Edwards. We had flown together out there, and he for 5 years could not tell anybody that he worked for Northrop, and finally after 5 years he could say, yeah, I worked for Northrop. But then for another 2 years he couldn't even say he was a pilot, let alone what he was working on. So yeah, very secret program, very interesting. But we're getting better here now. The F-16 is basically uncontrollable without the flight control computers. And it will essentially, if you lost all the augmentation, the stability augmentation, the aircraft would go out of control in approximately 9/10 of a second. If the pilot only had direct stick to surface movement. And I like this picture because I was the one chasing it. With a photographer in back. Of course, he's the one taking the pictures. I'm doing the flying. And this is one of my chase pictures, so I like it. But the F-16, of course, proved to be a very good aircraft. The design had matured at this point, so a lot of the problems that existed with early design, especially in flight control systems, no longer was an issue. And of course, we got the space shuttle. Now that's kind of interesting. This was an spacecraft that again is a vehicle that was ahead of its time. The tiles were a weak point, and it was a good idea. It was always a desire to be able to essentially take off from a runway, which they couldn't do, of course, but take off from a runway, fly into space, and come back like an airplane. And it had a reasonably successful program, if you want to call it like that. It did a lot of good work, but they lost two of them in the course of the program. But it was kind of determined that, well, we're not quite ready for this. So guess what? We're back to this, using capsules again. And of course, a lot of the high-speed data initially came from the X-15, and of course here we have a winged platform. Now this was a hypersonic vehicle. It could go up Mach 5 and that. And its main issues, of course, were heating, and they had some issues with the program towards the end, because of the heating issues. And same thing with the XB-70. This aircraft actually developed a lot of the data that was used really to develop the Concord, and that's basically led to the ability of the consortium to actually build this aircraft. And this is a picture of the Concord that was involved in the accident before it was involved in the accident. That kind of goes without saying. And here's the DC-10-30 owned by Continental at the time. Now, I want to talk about the whole issue of the warnings that they had. Over the 27 years of service that the Concord had, there were 70 tire and wheel-related incidents, 7 of which caused serious damage to the aircraft or were potentially catastrophic. Okay, 70 down to 7. You had a lot of warning here. There was a lot of information that you needed to look at this. In fact, the NTSB said, hey, you guys need to look at this because you got a disaster waiting to happen. And that's what finally happened. I'm going to talk about a couple of the incidents. I mean, this is what was telling the guys, hey, you got a problem. You need to address this. On June 13 of 79, the number 5 and 6 tires blew out during a takeoff from Washington Dulles, and fragments of the tires and the rims damaged the number 2 engine, punctured 3 fuel cells, severed several hydraulic lines and electrical wires, and tore a large hole in the top of the wing over the wheel well area. They were able to bring it back. On July 21st, 79, another blown tire incident during a takeoff from Dulles. That incident, they got a little bit concerned, and they issued an airworthiness directive, and they issued some technical information calling for revised procedures. This included inspection of each wheel, tire for condition, pressure, and temperature prior to each takeoff, and In addition, the crews were advised that the landing gear should not be raised when you have a wheel tire problem. Well, that's fairly normal. If you have a problem with a tire, with something like that, it's best to leave the gear down, because you don't want it necessarily even to jam in the gear well. At least if you got something down there to roll on when you come into land, that's better than nothing. And in August of '81, British Airways Concord, taking off from New York, suffered a blowout, damaged landing gear doors, engine, and fuel tank. On November of '85, a tire burst on a British Airways Concord leaving Heathrow, causing damage to landing gear door and fuel tank. 2 engines were damaged as a result of the accident. January '88, again, British Airways leaving Heathrow lost 4 bolts from its landing gear wheel, and a fuel tank was punctured. On July of '93, a tire burst on a British Airways Concord during landing at Heathrow, causing substantial ingestion damage to the number 3 engine and damaging the landing gear and wing and puncturing an empty fuel tank. In October of '93, a tire burst on a British Airways Concord during taxi to Heathrow, puncturing the wing, damaging the fuel tanks, and causing a major fuel leak. Now, the whole thing here is you got an issue with the design being a delta wing. No leading edge, no trailing edge devices. Speeds are going to be higher. Okay, if speeds are going to be higher, you have to take much more care of the possibility of damage, because it's the old kinetic energy, 1 FmV². You throw a rotating tire off at the higher speeds, you've got to have the shielding. And they later, they tried to correct this by installing Kevlar and stuff like that and doing certain shielding procedures. But the Concord was never really financially beneficial. It never made a profit. It was more of a national pride sort of airline, and it's a beautiful aircraft. I mean, it's unfortunate it had this demise, but these design errors led to that. And it was before its time, not properly designed. And by that, I'm talking about there probably material issues, because if you design this aircraft now, you would know better to shield the tanks better, to do certain things to minimize damage like this. But once this tank ruptured, flames went into the 2 engines close together, and they flamed out. They just didn't have the thrust. They were losing control. They actually did virtually a 180-degree turn before they came around and crashed into the hotel. And just as a side note, the DC-10-30 didn't have a very good future either, but it didn't involve anybody dying, fortunately, and it ended up basically in the trash at a boneyard. So it had a rather inglorious ending also. So I hope you found that interesting. Thanks for watching.